Good morning, afternoon, evening, Algebra 2 class. This is for Friday's lesson, March 28th. Hope everybody's doing well and adapting to our new way of life. Today, a couple things. If you have not done these following things, I want you to pause the video here in just a moment before you watch this video. First, I want you to watch that Patrick JMT video that's on the March 26th announcements page. He has a very nice voice, better than mine, and way of explaining the various applications of the properties of exponents. Has a much better handwriting, and you kind of looks the way it's presented. If you haven't watched it, you're kind of looking over his right shoulder as he's talking and showing you how to solve exponential problems. So if you haven't watched it, go ahead and watch that. Then once you've watched that, then download the handwritten problem set that I attached on Thursday the 26th. There's 14 handwritten problems, and I want you to try it and see how well you do before you watch me walk through those 14 problems. So go ahead and just, if you haven't done those two things, pause the tape for, the video is, Patrick JMT video is approximately 12 minutes, and it shouldn't take you any more than 12 minutes to do the 14 problems that are on the page. So well under a half hour, you can accomplish all that. Then once you've done that, go ahead and resume this particular video. And I'm going to walk you through the actual problems I gave you, applying the properties of exponents, similarly to how the Patrick videos did for you. Okay? So just to kind of clarify and bring you back to Algebra 1 2 years ago, is the correct terminology is like the C's here, the X's here are the bases, B-A-S-E-S, and of course these are the exponents. And in these first two problems, we're multiplying identical bases. I mean, this could be C and C, it could be F and F, it could be 13 and 13, but they're identical bases with exponents. And the only rule you need to remember, fairly straightforward, is that we actually add the exponents. C cubed times C squared actually equals C to the fifth, okay? And if you think of it, C cubed is C times C times C, and C squared is just C times C. So you've got squared, cubed to the fourth and to the fifth, with the final answer being C to the fifth. All right? Similarly, here we have x to the 12th times x to the negative fourth. All right, so let's talk about negative exponents. To address negative exponents, you just take the reciprocal of the base and exponent and change the sign of the exponent. So x to the negative fourth is equivalent to 1 over x to the fourth power. So similarly, this would be x to the 12th over x to the fourth. This right here on the left is identical to what you were initially presented. So when you're dividing identical bases with exponents, you actually subtract the denominator exponent from the numerator exponent. So this would be x to the 12th over x to the fourth would be equal x to the 8th. 12 minus 4 is 8. And if we did it that long-wise, let's just, to simplify things due to the board space I have, if you had x to the fourth over x squared, that is the same as x times x times x times x on the top, on the numerator, over x times x, all right? So these equate to 1, or cancel out. These equate to 1, and what do you have left? X times x, which would equal x squared. So here's kind of an abbreviated version of this larger problem. So x to the fourth over x squared equals x squared. Okay? So the next problem, number 3, is you've got a to the third power, and all of that is squared. All right? So it's the same as going a to the third, another way you could look at it, as times a to the third. All right? And using the same application we did there, 3 plus 3 is 6, so that's a to the sixth. Another way to look at that is it's just, instead of adding exponents, like we did in problems 1 and 2, you're going to multiply that. 2 times 3 is 6. So a to the third, with all of that being squared, is equivalent to a to the sixth. Okay? Problem number 4. You've got b to the negative 2 power. All right? Never, 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 to me or on your any standardized test, be it SAT, PSAT, ACT, will an answer, your final answer, be expressed with a negative exponent. Always convert those to a positive exponent. And b to the negative 2 power is equivalent, remember we said we just take the reciprocal, keep the value, change the sign of the exponent, is equivalent to 1 over b squared. Hope that makes sense. All right. I'm going to skip over here because I'm going to have to kind of step out of the screen here for a moment because my producer and cameraman didn't show up today, so I'm a one-man operation. We're going to convert these, we're going to do 8 through 11, and then we'll jump to the bottom half of the page during the second or last half of the video. Okay, so in number 8, we've got a squared over a to the negative 3rd power. And we just talked about to convert negative exponents to positive exponents is take the reciprocal and change the sign. So this is actually equivalent to a squared times a cubed, right? Because all we did is we took the reciprocal of 1 over a to the negative 3rd, and that is equivalent to a to the 3rd power, all right? So now we're in a similar situation as what we had in number 1. So we're just going to add those 2 exponents. So our final answer is going to be a to the 5th. So that's our final answer. All right. Hope that makes sense. Moving on to number 9. All right. So we're going to kind of now think back into Algebra 1, and we're going to address, we've got multiple bases here that are not like terms. So we're going to address the like terms individually to come up with a final answer. So if you kind of box things off, there's really 2 parts. There's the x's and the y's. So if I've got x squared over x, that's the same as this, right? And x over x would cancel out, or 2 minus 1 is 1. So I've got x squared over x is equivalent or equates to x, right? Make sense? Now similarly, we've got y to the 4th over y squared. So the easiest thing is to subtract 4 from 2, and we've got y squared. Or applying the same thought process to the y's, you've got y to the 4th is y times y over y times y, right? So that equates to 1, that equates to 1, and you're left with y times y for the y squared. All right, next. Again, applying the same properties for exponents on this one, except now we've actually got, instead of variables, we've actually got a coefficient or an actual integer value to use. So we've got 2 cubed over 2 squared, right? So if we look at that and apply the same thought process, we have 2 times 2 times 2 over 2 times 2, right? Cancels, cancels, and you're left with 2. All right? Now we have c to the 4th over c to the 4th. That's kind of like having c over c, right? Which equals 1. Anything over itself always equals 1. So our final answer for number 10 is just going to be 2. Hope that makes sense. If it doesn't, hop on my office hours on Friday from 9 to 10. Today we actually ran till 10:30. Hop on the office hours and I can walk you through some specific problems. All right, next problem, number 11. All right, so now we've got 8 m to the 3rd, m to the 2nd over 4, m to the 1st, m to the cube. So we're going to kind of break it up into 3 parts. All right, 8 over 4 is 2. That's simple enough. You've got m cubed over m, so 3 minus 1 is 2. So now we got 2m squared. And we got n squared over n to the 3rd. So we've got, this would be a little kind of the opposite of some of the stuff we did earlier. So we got n times n over n times n times n, right? Equals 1, equals 1. I got 1 n left on the bottom. So my final answer is 2m squared over n. Hope all that makes sense. I'm going to pause just for a moment as I reboot everything. All right, give me 1 second to clean the board, look over what you've done, and we'll do these bottom 8 problems next. I hope from those top 8 that we did that some of this is making sense. Like I said, if you want some little more simplified clarification of how to complete these, that Patrick video is absolutely outstanding. All right, so let's see. We just got 6 on the bottom here. So we got 5, 6, 7, and then 12, 13, 14. All right, so we got 1 over d to the negative 2. All right, so we take the reciprocal of that and change the sign of the exponent. Like I said, I'll reiterate. Both on my quizzes and tests and any standardized tests that you may be taking, you never want to give an answer with a negative exponent. Always in a positive format. Even though some of the possible selections to choose from the answer will have a negative exponent. You never want a negative exponent. So in this situation, 1 over d to the negative 2 power is equivalent to d over 2. We just took the reciprocal and changed the sign. All right. An easier way to solve this is this x to the negative 2 is, the way I would address that is x squared. Again, I take the reciprocal, change the sign of the exponent, so our final answer would be 1 over x to the 6th. All right? So now you should be getting the hang of things, and if you haven't done it, I'm going to just stop for a second and let you do that one, and then I'll put the answer up there. Applying the same mechanics, methodologies, and thought processes that we did in number 6, but it's kind of in a reverse format of numerator and denominator. So y to the negative 1, to fix that before I kind of solve it, would be equivalent to y here, or y to the first, right? If there's no exponent there, it's always to the first power. So y times y, remember when we have identical bases, we add the exponents, so that's y squared. All right, over here, all right? So this is equivalent to 1 over a to the 4th times 1 over a to the 3rd, which now equals 1 over a to the 7th. All right? Now, this should be fairly straightforward. We got identical bases, 3 of them, with exponents, 5, negative 4, and you know that's just a 1. So 5 plus negative 4 is 1. So I got x to the 1 after I've addressed these first 2, and then to multiply it times x again, we're down to a final answer of x squared. Similarly, we've got c to the 5th times c to the negative 2nd times c to the 2nd, all right, equals something. All right, think about it for a minute. I'm going to let you think about it before I put the answer up there. What strikes, now that you have, what strikes me is this is the same as c squared over c squared, right? So that cancels or results in 1, and what do I have left? C to the 5th. Okay, after this video, the Patrick video, I'm hoping you feel pretty comfortable with how you are going to solve various problems with exponents. And this is a fairly hot topic on standardized tests, so if you're getting ready to take SATs or ACTs, you need this basic knowledge on how to simplify and solve exponential problems. Also, talk with Ms. Dolmage, you're going to use a lot of this next year in pre-cal. So you want to become pretty proficient on how to resolve, simplify, and solve problems that have multiple exponents. I hope that makes sense to you. If it doesn't, I'll see you Friday morning between 9 and 10 on our office hours. Today we went till 10:30, so I have no problem going later as long as we got guys on there that want some additional clarification on helping solve these. Hope you guys are doing fine, and we look forward to seeing you again real soon. Bye-bye.